All right, next question. So A is located down on the y-axis and C is up here. I'm 99% certain the problem told us it was a rectangle. And we knew that, you know, B was out here somewhere and C's over here like such. So D's got to be down here, just in that general vicinity. And they tell us that this diagonal is running parallel to the axis. So this does use quite a bit of geometry, actually. All right, so the first thing they ask us to do is find the gradient. So remember, that's just a European word for slope. Find the slope of sides AD and CD in terms of h. So they tell us that the x-coordinate of D, we're going to call it h. We don't know what it is. All right, so gradient, the slope of AD in terms of h. Turns out we don't know what this is either, and we really need it. Otherwise, we would have another variable there, and we wouldn't just be writing it in terms of h. So the first thing I'm going to do is go back and just remember what I know about rectangles. In a rectangle, all the angles are right angles. The diagonals are congruent to each other and they bisect one another. They meet in the middle. So I'm going to look at this diagonal that I have, and I could have done this on graph paper, and I even just barely sketched it, and I think it's accurate. That is indeed the middle. But rather than guess, remember the midpoint formula. Add the x's, 12 and 0, and divide by 2. So, you know, 12 plus 0 divided by 2 gives us 6. And add the y's. 14 plus the negative 2. That's 12. Cut that in half, and it's 6. So they meet at 6, 6. Which is important because they told us that this diagonal is running parallel to the x-axis. That means its vertical height, it's hitting at 6 on the y-axis, it's 6 all the way across. So I know that the y-coordinate of this point is 6. I also know that the y-coordinate of B over here is 6. I don't know its x-coordinate, okay? All right, so now the only thing that I don't know is h. So I should be able to find the slope of this with, only in terms of h, because nothing else is missing. So we're going to do this y-coordinate minus that one. 6 minus negative 2 is 8 over h minus 0, just using our slope formula. Y sub 2 over y sub 1 over x sub 2 minus x sub 1. I'm sure you guys know that. So 8 over h. So the slope of AD, the gradient, was 8 over h. We have to do it for CD as well. So the same thing, subtract the y's, 14 minus 6 is 8, and then subtract the x's. So we have 12 minus h. Okay, that is technically, I don't know what they call it in ACE, but that's what we would have called M in algebra. It's our slope. All right, so now that we know that, how are we going to find the actual x-coordinate of points D and B? Well, let's go back and let's use the fact that the rectangles not only bisect each other, but they're also congruent. So let's simply find the length of this diagonal. We're going to use the distance formula, okay? So to find the length of AC, the distance from A to C is, remember the distance formula says that you subtract the x's, that's 12 and 0, subtract the x's and square that, and subtract the y's. 14 minus negative 2 is 16. Okay, so we have 12 squared minus 16 squared. 12 squared is 144, 16 squared is 256. Add those together and we end up with the square root of 400. So we know that that diagonal is 20 units long. So this one must be 20 units long as well. Okay, so from my far left coordinate all the way over to here, it has to be 20. Hold on a second, I forgot what I did. So then, oh, I know what I did. So I still have some unknowns, right? I don't know this either, though. If I had either starting point, I'd be good to go. So I just called this some other random variable W. So here's one thing I know. I know that from W all the way over to H is 20. And this is the larger number. So I'm going to solve a system of equations here. This is to find the x coordinates. I know that H minus W has to equal 20. And I also know in a rectangle that these are right angles, right? So these slopes that we just found up here are going to be opposite reciprocals of each other, opposite reciprocals. So in order for them to be equal, I would have to negate and flip one. Okay, so remember, if one slope was 3, the other one would be negative 1/3. If I wanted these two to be equal, I would have to flip one of them and change its sign. So I'm going to do that here. Actually, how did I end up doing this? I'll do it differently. This is probably easier. Let's just go ahead and find the slope of this side in terms of W. So we would do 6 minus negative 2, which gives us 8 over W minus 0. So this segment has a slope of 8 over W, and it is running parallel to this side. So, and that one was CD, and CD was the one that had this slope. Let's set those two things equal to each other. Okay, so 8 over W is equal to 8 over 12 minus H. We're going to take cross products. So 8W is equal to, distribute the 8 through the binomial, it's equal to 96 minus 8H. Bring the 8H over, so we have 8W minus 8H equals 96. Let's go ahead and divide everything by 8. W minus H equals 12. And then we have H minus W equals 20. So I'm going to write the W first. Negative W, it's positive H, plus H equals 20. That's not right. Something's wrong. Hold on. Oh, when I bring this 8H over, that's positive. Sorry, that's a positive 8H. So this is a positive H. Okay, so when I add these two equations together using elimination, we get 2H equals 32, divide both sides by 2, and H is 16. If H is 16, 16 minus what gives us 20, W has to be a negative 4. All right, H is the x-coordinate of D, so the x-coordinate of D is 16, and negative 4 was the x-coordinate of B. So the x-coordinate of B is negative 4. And that does kind of make sense looking at the diagram, all right? Finally, they want us to find the area of the rectangle. Well, in order to find the area of the rectangle, I need to find the lengths of the sides. So let's just go ahead and do that really quick. We're going to use the distance formula quickly. We're going to find the distance from A to D, and we're also going to find the distance from C to D, distance formula. So A to D, remember H is 16, okay? So it's going to be subtract the x's, 16 minus 0, the square root. 16 minus 0 is just 16 squared. Subtract the y's, 6 minus negative 2 is just 8 squared. So we have 256 plus 64. We're taking the square root of all of that. Let's see. That's going to be 10, 12, 320, I think. You guys might want to check that. Let's find CD as well. So for CD, I have 14 minus 6. That's going to be 8 squared, and then 12 minus 16 plus a negative 4 squared. So we end up with 64 plus 16, or the square root of 80. Check my math. I really would check my math. Okay, and now we have to multiply these two things together. All right, you guys, I'm using my phone, and I actually don't have a calculator at home. So multiply them together. We actually might be surprised when you do that. So it's going to be the square root of 320 times 80. You might get a perfect square. I can probably read, let's see, what do we end up here? I'm just going to break this down really fast. 320, I know, is 16 times 20, which is 16 times 4 times 5. We're going to be able to take the square root of both of those things. 80 is 16 times 5. I can take the square root of that. So I'm just simplifying this really quick. If you multiply those together and take the square root, it looks like it's going to be a perfect square to me. So the square root of 16 comes out as 4. The square root of 4 comes out as 2. The square root of 16 comes out as 4. And what I have here is 5 times 5, which is 25. Clearly that's going to be 5. So we have 4 times 2 times 4 times 5, or 16 times 10. I'm pretty sure it's 160 square units for the area.